Hello people, good to see you again. So today we will be practicing some questions on the topic ray optics and optical instruments. Every year, one or two questions in exam are based on this chapter. So without further ado, let's jump to question number 1. Question number 1 states that a ray of light is incident on a prism ABC of refractive index 3 as it is shown in the figure. Now we need to find the angle of incidence for which the deviation of light ray by the prism ABC is minimum, and also by what angle the second prism must be rotated so that the final rays suffer a net minimum deviation. So to understand this question, let's draw prism ABC. Now if I draw prism ABC, this is going to be how it looks. That is A, B and C. So light comes from this side and then it bends. So this is the incident ray and this is the reflected ray. Now this angle is going to be I1 and this angle, that is this one, is going to be I2. Similarly, there are going to be R1 and R2 angles. So when I'm going to extend these lines, so this angle is going to be what? R1, and this angle here is going to be nothing but R2, right? So the point is that if I'm going to join ABC and DE, then it will look somewhat like this. That is, this is A, B, C, D and E. And the angle is like this. So this is how the line is going to travel. Now we know that I1 equals to I2 equals to I. Okay. So I1 equals to I2 equals to I. Also R1 equals to R2 equals to R. Now R1 plus R2 is going to be what? R1 plus R2, they are going to be A. And R is going to be what? Because we know that R1 and R2 are equal. So R is going to be nothing but A by 2. That is nothing but what? 30 degrees. Now using Snell's law, we know that sine I1 upon sine R2 is nothing but mu. And we know that sine R2 is nothing but what? 30 degrees. Because R2 is what? 30 degrees. So because of that, I can write that sine I1 is nothing but under root of 3, that is mu, times sine R1, where sine R1 is what? Sine 30 degrees. So therefore, sine I1 equals to nothing but under root of 3 by 2, where I1 is going to be nothing but 60 degrees. So when the prism is rotated anti-clockwise by 60 degrees, the combined prism will become what? A slab, as I have drawn in this case, that is in figure 2. And in this case, the net deviation by prism will be 0, as the deviation by the two prisms will be what? Equal and opposite. So the correct answer is what? Correct answer is option number C, that is 60 degrees and 60 degrees. Let's move on to question number 2. Question number 2 states that which of the following observations cannot be explained by Tyndall effect? Number 1, sunlight entering a smoke-filled dark room from a tiny hole. Number 2, sunlight entering from a canopy of dense forest. Number 3, speed of light in vacuum is 3 into 10 to the power 8 meters per second. And number 4, light passed through a milk solution. Now Tyndall effect is what? It's scattering of light in a medium containing small suspended particles. It's observed in many natural phenomena. Some common phenomena include what? Like the sunlight entering through forest canopy, sunlight entering a dark room from a small hole, and also the light that passed through a milk solution. Now since the Tyndall effect is observed in medium containing fine suspended particles, it cannot explain that the speed of light is what? 3 into 10 to the power 8 meters per second. Correct? So the correct option here is going to be option number C. Let's move on to next question. Next question states that a double convex lens is made up of glass of refractive index 1.5. Its focal length is 30 centimeters. Then the radius of curvature of each of the curved surface is going to be what? Now, given a double convex lens is made up of glass where the refractive index is mu, that is 1.5, and focal length is 30. So, refractive index, that is termed as mu, is 1.5, and focal length, that is nothing but small f, is nothing but 30 centimeters here. Now, as it is a double convex lens, so let R1 be R and R2 be negative of that. That is, I am saying that R1 is nothing but positive of R, and R2 is nothing but R2 is negative of that R. Now, according to the lens maker's formula, I can write that 1 upon F will be equal to mu minus 1. This is mu. So, mu minus 1 times 1 upon R1 minus 1 upon R2. So, this is going to be the formula. Now, we need to use the values that is given in this formula. So, I can write that it is 1 upon 30 equals to mu is 1.5. So, 1.5 minus 1 is nothing but 0.5. And then we know that R1 is what? Positive of R, and R2 is what? Negative of R. So, if I am going to take negative of R here, so it's going to be 1 upon R plus 1 upon R. And 1 upon R plus 1 upon R here is going to be what? 2 upon R. So, if I am going to solve this, I'll get that R is going to be nothing but 2 into 30 into 0.5. So, therefore, the radius of curvature is going to be what? The radius of curvature is going to be 30 centimeters. So, the correct answer is option number A, that is 30 centimeters. I hope you people have understood how I solved this. It was nothing but it was 1 upon R minus 1 upon negative of R. When negative of R went here, I would say plus R, and this I'll just erase it off. Correct? Then 1 upon R plus 1 upon R is nothing but 2 by R. And this is what I wrote it here. So I hope you have understood this. So let's move on to question number 4. Question number 4 states that a plane convex lens of focal length 12 centimeters is made from a glass, and mu of glass is nothing but 3 by 2. It is to be used in air. Then the radius of curved surface is going to be what? We need to find what? The radius of the curved surface. Now we know that f is nothing but 12 centimeter. So focal length is nothing but what? 12 centimeter. And mu is nothing but mu is what? 3 by 2. And R2 is nothing but it is infinity, that is infinite. Therefore, when I am going to use the formula, can I write that 1 upon F is nothing but it is mu minus 1, this is going to be mu, times 1 upon R1 minus 1 upon R2. So, this is going to be the formula and we all know this. So, I am going to substitute the values in this formula. So, it will be what? It will be 1 upon 12 equals to mu is nothing but 3 by 2 minus 1. Then R1 is going to be R1 itself minus, and R2 is infinity, so 1 upon infinity. We know that 1 upon infinity is nothing but 0. So 1 upon infinity is going to be 0. So this is going to be 1 upon 12 equals to 3 minus 2 is 1 by 2 times 1 upon R1. So from this I can say that R1 is nothing but R1 is 12 by 2 and it is nothing but 6 centimeters. So hence the correct answer is going to be what? Option number C, that is 6 centimeters. I hope you people have understood till here. So now let's move on to the last question. The last question states that a lens behaves as a converging lens in air and diverging lens in water. So the refractive index of the material of the lens is going to be what? Now since it is behaving as converging in air, so its mu has to be what? Greater than 1. And because why? Because the mu of air is nothing but what? 1. The refractive index is what? Equal to 1 of air. and also it's behaving diverging in water, so mu has to be less than what? Mu has to be less than 1.33. Why? Because mu of water is nothing but 1.33. So the correct answer is going to be what? Option number B, that is somewhat between 1 and 1.33. Why? Because mu is greater than 1 but less than 1.33. So the correct answer is going to be option number B, that is between 1 and 1.33. So I hope you people have understood how to tackle problems of ray optics and optical instruments. You can go to EduRev and attempt these tests to understand this chapter in depth. You can unlock all the logged videos, documents and tests of JEE with EduRev Infinity Plan and ace your exams at less than 80 rupees per month. Thank you.